Hello, myself Mukunda, and my unique ID is E0222050. So, so today I will be speaking on a topic that is both timely and critical: the role of software engineering, the software defining networking, or SDN, in IoT security that revolutionizes protection for a connected world. We are all aware that Internet of Things (IoT) has already become a part of our daily lives. Smartwatches, connected cars, industrial sensors, traffic monitoring systems, and even medical implants. All of these are examples of IoT. So, but with the explosion of this connectivity comes with the risk of exposure as well. The more we connect, the more we open doors for cyber attacks. The traditional security models are not designed for this scale and complexity. This is where HDN, that is software defined networking, plays a crucial role. HDN gives a centralized control, programmability, and visibility. It qualifies that makes the networks more flexible and intelligent and secure. So in this session, we will cover a few topics, that is the security challenges in IoT, the architecture and layers of SDN, and how SDN transforms IoT security, a case study on SDN with AI, and security risk within SDN itself, mitigation techniques, real world applications, and future directions. By the end of this, I hope you are convinced with that SDN is not just an option but a necessity for securing the future of IoT. So, coming into the next slide, IoT security challenge, complexity at massive scale. So, IoT is expanding faster than any technology in history. By 2025, it estimates that there will be over 30 billion connected IoT devices worldwide. But there are three big problems. Resource constraints. That is, most IoT devices are small, low cost, and have a limited processing power. They cannot run advanced firewalls, intrusion detection systems, or heavy encryption. And second is the fragmentation, where there is no single standard. Different devices use different operating systems, protocols, and vendors. This makes the network wide security management extremely difficult. And the third one, that is the weak security practices. So many IoT devices come with default passwords, lack encryption, and use outdated software. This opens the door for attackers to put vulnerability attacks and hacking. So the consequences are huge in this, like data breaches exposing sensitive personal or industrial information, large-scale botnet attacks, such as the Mirai attack in 2016, which hijacked a million of IoT devices to bring down major websites, and ransomware targeting smart infrastructure, hospital, or transportation. So, in short, IoT without strong security is like building a smart city without locks on the doors. So, the next slide. So, what is software defined networking? That is SDN. So, traditional networks are hardware centric, like the routers and switches decide for themselves, like how to forward the traffic. This makes networks rigid, complex, and hard to secure at large scale. So, SDN introduces a new style that it separates the network into two planes: the control plane and the data plane. So in the control plane, the brain that decides how traffic flows, and in the data plane, the body that forwards the packets. So instead of many distributed brains, SDN centralizes decision making into a controller. This controller communicates with the network devices using the southbound APIs, that is in the open flow. So at the same time, applications like intrusion detection or firewalls communicate with the controller via northbound APIs. This makes the network programmable and flexible. So, but that being here, coming into the SDN architecture and layer. Now, SDN architecture here. The SDN architecture is organized into three primary layers: the application layer, the control layer, and the infrastructure layer. So in the application layer, the top layer where the network applications and business policies reside. Example in the security monitoring, firewalls, QoS, that is quality of service, load balancers. Developers can write security applications that use the network's global view, and the control layer, that acts as the SDN controller. It is the brain of the network. It collects information from all devices and enforces policies, controllers like ONOS, Open Daylight, that are very popular. And it is also responsible for path calculation, traffic management, and policy enforcement. Next is the infrastructure layer. It acts as the data plane. It is the bottommost layer where the switches, routers, and gateways and IoT devices stay. So these devices no longer make independent decisions. They only follow the instructions from the controller. This separation of layers allows innovation and faster deployment of new security solutions. So how HDN transforms IoT security. Now we will see how it enhances the IoT security in a way that uh, it centralizes and abstracts the network infrastructure. So it introduced a new era of security adaptation for connected devices. So first is the centralized control. So instead of securing each IoT device individually, HDN allows central brain to enforce rules across the network. Dynamic threat response. The SDN controllers monitor traffic in real time. If they detect any anomaly, for example, a smart camera suddenly sending gigabytes of traffic, they can instantly block, isolate, or reroute the device. And granular policy enforcement. Administrators can set rules like sensor A can only talk to server B or port 443 or any port. So, such rules prevent attackers from moving laterally across the network. The network wide visibility, that is the comprehensive network visibility, the controller sees all devices, all traffic flows. This makes it easier to spot hidden patterns and launch forensic investigations after an attack. Overall, SDN converts IoT networks from reactive and fragmented into proactive, unified, adaptive solutions. So that is the next slide is the case study. That is how SDN security is enhanced with deep learning. So researchers created a framework where deep neural networks, that is DNNs, learn complex attack patterns. The convolutional neural network CNNs processed network packet sequences, that is the long-term short memory, which is LSTM. This network captures temporal patterns of IoT traffic. With this achieved a 99% accuracy in identifying attacks. They also used SMOT. SMOT here refers to synthetic minority oversampling technique. So this is a technique used to generate synthetic attack data. It improves the detection of rare attacks. This shows that when AI and SDN works together, IoT networks becomes intelligent defenders, capable of spotting and stopping any threats. So the next is the SDN security risk. The controller as a high value target. So, but SDN itself is not invincible, right? So then let's see the parameters. Controller as a target. The SDN controller is the brain. Like if a hacker attacks it with a DOS attack, the entire network could collapse. And data plane exploits. The attackers can flood switches with fake flows rules, like only conversation with the port 443 server. So it might create a flow of rules, exhausting memory and degrading performance of the all the nodes. And man in the middle attacks, that is man in the middle risk, like if a communication between the controller and switch is not encrypted, attackers can intercept, alter, or inject malicious rules. So that is where this communication protocols fall in. So SDN improves security, but also because it has a high target accuracy. So we have seen these attacks. So what are the mitigation strategies? So let's see these strategies. The mitigation SDN IoT security threats. Uh, to address these risks, multiple strategies are used, like controller redundancy, where multiple controllers ensure high availability to secure it, and rate limiting. It prevents the traffic flooding from overwhelming controllers, a lot of controllers in the network, and strong encryption and authentication using TLS handshakes and certificates to secure communication. It encrypts and decrypts the data such that it can't be malicious. And machine learning based anomalies detections, that includes the identifying the unusual behavior proactively. And blockchain integration, that is blockchain and certified access for trusted device identities and tamper-proof locks. The technology can be integrated for decentralized identity where there is no central control. So the identity can be easily managed by logging for IoT device interactions, right? So with these defenses, SDN enabled IoT that IoT can remain secure. The Let's see the real world applications now. Like such one application is the synergy. SDN enables scalable, flexible, and secure IoT networks. So, yeah, the real world applications like smart cities, healthcare, industrial IoT, and smart homes. There are various sectors where SDN plays an important role. So, in smart cities, like the SDN helps manage secure traffic sensors, smart lighting, and surveillance systems. And in healthcare, it protects the sensitive patient data from wearable devices and remote monitoring systems. Like these patients can have access over who can access their data. And industrial IoT, where it ensures the secure communication for robotics, sensors, and factory automation. And other than that, smart homes, where isolated devices like smart TVs and cameras are used to prevent hacking. And so, in every sector, HDN provides the scalable centralized security that IoT needs. The future directions towards a smarter, safer IoT ecosystem. So, HDN has an important future in IoT. It is a very promising future. So, such one that is AI driven autonomous networks. So, networks, it doesn't just include the networks, it also includes the networks that not only detect but also automatically neutralize attacks. And standardization and OpenAIs, increased standardization and OpenAIs will be critical such that like it improves the compatibility across devices and reduces vendor lock-in. Privacy preserving technologies, that is advanced encryption and blockchain for secure IoT data sharing. And HDN in critical infrastructure, we anticipate a growing adoption, right? Like the adoption in power grids, power water items, and transports to protect against cyber warfare. That is, it enables a rapid response in safeguarding the network from cyber threats. So, this future is not just about security, but about creating an IoT ecosystem that is trustworthy, scalable, and self defending, that doesn't depend on our commands. So, the conclusion, uh, the overall part of what we have seen till now about SDN. So, to conclude, IoT is growing at a very high space, but it faces massive security challenges. Like Agent is a game-changing technology that provides centralized control, programmability, and visibility. So, together with AI, blockchain, and enhanced advanced encryption, Agent enables IoT networks such that they are adaptive, secure, and safe. The future of IoT security lies in embracing HDN, not just as a technology, but as a strategic imperative for a safe digital transformation. Thank you.